start with the first set of numbers that you learn when you're a baby. And they are called the set of natural or counting. Those are the set of natural or counting numbers. Those and examples of those numbers are 1, 2, 3, 4, and so on. Okay? So when we refer to natural or counting numbers, think of 1, 2, 3, 4. Did we say 3.5? Did your mom and dad say 3, 3.5, 4, 4.5? No, we did not. They did not say that. Okay. So you get a little older after you can count. And you're in probably maybe kindergarten. They probably introduced the next set of numbers to you. And it only added one number. What number do you think you add to the set of natural numbers?
0.
0. Okay, so when you take the natural numbers and put a 0 in front, so starting with 0, 1, 2, 3, does anyone know what this set of numbers is called?
Whole.
Whole. Whole. These are the set of whole numbers. So everybody look at this example right here. It says list all of the whole numbers that are greater than -2. How would you answer that question? What are the set of, what's the set? So here is the set. What are the whole numbers greater than -2? 0, 1, 2. So we wouldn't say -1, right? Why aren't we going to say -1? Because it's not a whole number. So we don't, even though it is bigger than -2, it does not satisfy this requirement. Okay, so we're moving along, grade school, and they start adding numbers on a number. They start making you graph numbers on a number line. Okay, so what we have so far, here's your number line. And we know 0, 1, 2, 3. What do they do after that?
Church.
Where do they go from here? Negative. So when we take the set of whole numbers and we graph their opposites, here's the opposite. The opposite of 1 is -1. The opposite of 2 is -2. The opposite of 3 is -3. And we order the further this way we go, the smaller the number is. Does anyone know what these numbers are called? These are the set of, anyone know? They are integers. So dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Those are the integers. Okay, next. You're probably now, I would say, in 3rd grade. And you start adding and subtracting decimals and fractions. And that's where you guys start struggling. Fractions are, you would know what they're called? Fractions are any number that can be written as a fraction is a percent. Starts with the letter R. It's a rational number. A ratio is a fraction. So rational numbers are all numbers that can be written as a ratio of 2 integers. They are decimals that repeat or terminate. You know what terminate means? They end. And they are fractions. So if you can make a fraction a ratio of 2 integers, if you can find me a decimal like 0.5, 0.5, can you make that a fraction? Yeah, it's 1/2. Any I could give you a decimal, like 0.0375. That's considered a rational number. We could make this a fraction, you know that? It's 375 over a 1 with 3 zeros. I'm sorry, 4 zeros. There's 4 digits here, there's 4 zeros. 1, 2, 3, 4. And then you can reduce that too if you wanted to, but we're not getting into that. But anytime you have a decimal that ends or it repeats, what's an example of a repeating decimal? 0.333. Why is this a rational number? Because you can change 0.33 to 1/3. And that's a rational number. What's the opposite or the counterpart of a rational number?
Irrational.
An irrational number. You know how I think of irrational numbers? Is if you ever do something that upsets your parents, what happens? Your mom tells you, be home by 11 o'clock, and then you show up at 12. What happens? You're grounded for the rest of the summer. No cell phone, give me the keys to your car, I want you in by 10 o'clock till you're 21. Your mom's being irrational, she's being crazy. She's like, okay mom, relax, okay? So think of an irrational number as a crazy number. What's a crazy number? It's a number, it's a decimal that does not repeat or does not end. It's a non-terminating, doesn't repeat, kind of a number. Can anyone think of an example of a number that doesn't repeat, doesn't end, it's crazy, goes on forever? What? Pi, good, that's a good one. E is another one. Then we have square roots of 2, square root of 3, square root of 5, square root of 7, square root of 11. Okay, is the square root of 9 an irrational number? No, why not?
This 3.
Because that's equal to 3. And 3 is a terminating decimal. It's actually a natural number, it's a whole number, it's an integer, it's a rational number. See, I can make the square root of 9 all of these numbers. It fits all of these. So it starts off as a natural number, and it's in the set of whole numbers. It's an integer. I can make 3 over 1 a fraction. And all of these numbers that I'm talking about are real numbers. All numbers, but I'm not, because I know you guys know imaginary numbers. An imaginary number is a number like, there's real numbers, and then I could break this off into another category, irrational, but we're not going there. A number that's not real would be like the square root of 4, negative 4. Square root of negative 4, you guys will say 2i. Yeah, you're right, but it's an imaginary number because you can't think of two numbers that multiply together that are the same. It'll give you negative 4. So that's an imaginary number. But we're going to work with imaginary numbers in, I think, chapter 4 is the chapter, imaginary numbers. But, so, you're going to be asked on your next test, on your first test actually, to classify numbers. So just like we just did here, what's the square root of 9? It is, what kind of a number is that? Square root of 9 is a whole number, it's a natural number, it's a whole number, it's an integer, it's a rational, it's a real. What if I said classify the number negative 7? Is it this number? No. Is it this number? No. Is it this number?
Yes.
So once it's this number, it's these two, it goes up like that. So negative 7 would be an integer. It would be a rational number, and it's real. They're all real. What if I said, what's the square root of 5? You would say it's an irrational and a real. They're all real, unless I do square root of negative 4, like that. Got it? Is this coming back to you? Do you remember this stuff at some point in your life? Okay, so I'm going to tell you right now, on your test, you're gonna have one of these kind of questions to classify these, so at some point, review these, what they are. All right, you gotta know, it's very important. Okay, now, do you remember in third grade, when we asked you, we gave you a number line, and we said graph these numbers? Let's say I gave you and so forth. If I said to plot graph 3, you'd put a dot right here, right? Okay, so this represents one quantity. Have you ever seen a number line that's going vertically? This is a horizontal number line, this is a vertical number line. I would take 0 and I'd do this, 1. So up would be positive numbers and down would be negative. Does everybody remember doing this in third grade or so forth? I don't recall what year you learned this. So this is a quantity and this is a quantity. If I take this number line and transpose it over this one, I would match the zeros. That's what I would do. So once you do that, so if I take that number line and I put it over here, what do you have? What have you created? You've created the rectangular coordinate system. You have quadrants. You have 4 regions. 1, 2, 3, 4. Those are your quadrants. How do you label quadrants? Quadrants are labeled starting in this region, this corner. These are quadrant 1. We use Roman numerals. Then you go counterclockwise. 2, 3, and 4. Everybody remember that? So if you want to write it on here, so we've got quadrant 1, we've got quadrant 2, we've got quadrant 3, and we've got quadrant 4. Does anyone remember the fancy name for this middle point right here? What's it called?
Origin.
It's the origin. You guys know that. And we label points with ordered pairs, right? It's with in parentheses and a comma. So now, can you all plot these 3 points and tell me what quadrants they are in? Sure, everyone should be able to do that. How do you plot or graph -2, 4? You start at the origin and you're gonna go 2 to the left and you're gonna go 4 up. Does everybody recall how to plot points?
Yes.
Over 2, up 4. What quadrant is that in? It's in 2. The next one, -3, 5, -5. 1, 2, 3, 4, 5. That's in quadrant 3. And then where is 0, -3? Where's it at? It's on the y-axis. Very good. And that's another thing you need to remember. Which axes are which? Now, are we always going to use x and y? No, you can use A and B. How do you know which is the horizontal axis and which is the vertical? You usually it's alphabetical. So x comes before y, so x is horizontal and y would be vertical. That's usually how you do it. But you'll start to see in this class that it's not always x and y. It could be 2 different letters. Okay. Now, let's see if you understand this last question. This would be a pre-calc question. In what quadrant or quadrants is xy greater than 0? That's a loaded question. First of all, what does xy mean? What does xy mean? X, what, y? Times. When we see 2 variables together, we understand it to be multiplication. So what does this sign mean? That means greater than 0. What does greater than 0 mean? And another way of saying greater than 0 means what? It means positive. So in what quadrants is the product of the x's and the y's going to give you a positive number? So let's look at these quadrants. In quadrant 1, the x values are what? Positive or negative? And what are the y's? Positive. How about quadrant 2? X's are negative and y's are positive. In quadrant 3, they're both negative, right? And in quadrant 4, it's positive x, negative y. So, look at these. We've got x and y, x and y, x and y, x and y. Tell me in what quadrant, if you were to multiply these types of numbers, would give you a positive number. 1 and 3, very good. Why 1 and 3? Because when you multiply two positive numbers, you get a positive, and when you multiply two negative numbers, you get a positive. So we're going to answer this first question with a 1 and a 3, and I bet you can answer this one now. What's 2 and 4? What does it mean, though? Janelle, what does it mean?
When you multiply them, you get a negative.
Very good. Very good. You get a negative. Less than 0 means a negative number. And why do these two give you a negative? Of a negative times a positive is a negative. Everyone good so far? Okay, the next set. Number 3, domain and range. You guys remember what domain and range is? Okay, what you have here, this is a relation. This is a relation. A relation and a relation. What is a relation? It's a set of ordered pairs. When you have a set of ordered pairs, that's a relation. We're a relation. This class is a relation. 7th hour. We are a relation. What are all the x values called? That's your domain. That's your inputs. Your y values are your outputs. So in every relation, they're going to ask you to state the domain. That just means what are the x values? What's the number that is on the horizontal axis? Now, when we list the domain, we list them in order from least to greatest, and we don't repeat. So how would you list the domain for this? What would you do? You would do a subset, and you would write, these are the x values, and you just list them in order. Right? In your range, you're going to write, what are you going to write for your range? First 0, then 4, then 6, and then 9. And I know they don't match up, but that's okay. I didn't ask you, I don't want a repeat of you listing the ordered pairs. I want you to list all the inputs and all the outputs. So you guys can do that for all these, right? So for this next one, what's the domain? How would you write the domain for this one? First -4, then -3, then what? And done. Now why didn't you repeat -2? Because we don't have to. It's like saying, list all the girls' first names in this class. If we have 3 Ashleys, I don't have to say Ashley, Ashley, Ashley. I just say Ashley. I don't have to list it 3 times. I just say list all the different names of girls. So think of it that way. What's the range? What's the smallest y value? -2. Then what? 1. Then what? Okay. Okay, let's move on. Here's another example, and here's another one. Now, what is a function? A function is a special type of a relation that for every x there's only one y. Okay, let's look at these 2 examples. Okay, are these functions for every x is there only one y? This one, yeah. If you see any x value repeating, it's not a function. So for the first example we did, that is a function. But the second one is not a function because -2 was repeated. So when you see any x value repeating, it's not a function. So here's a trick question for you right here, this next one. Let's name, what is the domain in this problem? Actually, before you name the domain, look at the relationship. And before we list the domain, because that's going to help you figure out if it's a function or not, how many of you think, just look at it really quick, how many people think this is not a function? This is not a function. Not. Raise your hand if you think it's not a function. How many people think this is a function? It is a function. Now, a lot of people get this wrong. Some of you guys didn't raise your hand. So I'm thinking you either don't know, but here you go. Here is the domain. Let's list the domain. It's -3, that's our smallest number, then -2, then 3, then 4, and then 9. Did I have any repeating? And that's why, yes, this is a function. As long as the x value does not repeat, it's a function. For the y values, you would say -3, 0, 3, 4, and you're good. But a lot of people get confused right here, right off the bat. This is a pre-calc question. You see that plus minus 3, and you know that something happens when you see multiple x values, but those are two different numbers. A lot of people think, no, it's not a function, but this one is. Now, if I were to have put a plus and minus 3 right here, well, there's a -3 right. If I did this, plus or minus 3, let's put a plus. I'll do plus and minus. There. Actually, no, I don't want to do that. That's going to confuse you. That's going to confuse you. If I make a T-chart and I do this. So I do 3 and then plus or minus 6 and 0 and 5. This one is not a function. Why? Because you've got 3 with 6 and 3 with -6 and 0, 5. So because this repeated, this 3 repeated, you have 3 with 6 and 3 with -6, this one would not be a function. This is not a function, okay? Any questions on that? This should all be reviewed for you guys. Last thing, actually there's one more thing here. How do you write equations? We normally have we have something on both sides of an equal to sign. Two expressions set equal to each other, that's an equation. Well, this is also a relation, and it may or may not be a function. For example, and we'll get to it at another time, but if I gave you something like this, here is, okay, here's two expressions set equal to each other. This is an equation. It's an equation. This is a relation. We're comparing x's and y's. I know what this thing looks like. This is a circle. It's a circle where the center is at the origin and the radius is 3. So this is what it looks like. Okay, that's the graph. All of these points lie on this, or satisfy this equation. Is this a function? No, it is not. Because I have for this, see this one right here? Or let's use this point right here. We've got 0, 3, and we also have 0, -3. So does this pass that function test? No, you have 2 zeros for x. So a circle is a relation, but it's not a function. But what about something like y equals 2x plus 3? This is a relation. We're comparing two different quantities here. And if I were to graph this, you guys remember, you start at 3 and you go up 2 and over 1. Remember this? Okay. Is this a function?
Yes.
It is. We learned the vertical line test. Remember that? See, this doesn't pass the vertical line test. When you draw a vertical line through, it hits in 2 spots. So this one's not a function for the vertical line test, and I just showed you also about looking at the x's and the y's. This one is a function. If it is a function, instead of using y, you'll use f of x. The name of this function, we will use this usually it's a fancy letter. Usually a F, G, and H are most common ones. But what you have here is a new way to write. It gets this privilege of writing this function notation. When you see that function notation, that fancy F, you know that it for every x there's only going to be one y value. Okay, so if it is a function, it's kind of like when you get your PhD, you can put DR in front of your name, right? Doctor. You are now a doctor. So that's what this, think of it that way. What you have here, inside here, this is going to be your input. This is your domain. We're going to evaluate a function by putting a number in here. And it could be a letter. It could be a letter, but right this second we're going to talk about if I asked you to evaluate f of 3. Do you recall what this means? If I say, what's f of 3? That means I want you to take 3, which is your domain, part of your domain, and I want you to plug it into this rule. That's your equation, your rule. So when you plug 3 in here, output what number? When you input 3, what comes out? 9. When you plug a 3 in here, 3 times 2 is 6, and plus 3 is 9. So f of 3, when you evaluate this function for 3, you put the 3 in here, 2 times 3 is 6, 6 plus 3 is 9. So f of 3 is 9. That would be an ordered pair. Whoops, I have 2 equal to signs. You have, when you have x is 3, y is 9. So your input is 3, your output is 9. That would be an ordered pair that would fall on this line. Now what if I said, so you have this here. So x is your input or your domain. The 2x plus 3 is your output. This is your output. The f is the name of the function. And this f of x, this whole thing, is also your output. So your output equals your output. Okay? Now, what if I said, what's f of a? What if I asked you to plug an a in here? What would you do? What would you get for an answer? What's f of a? You would plug an a in here and you'd have 2a plus 3. And that's it. Okay, remember it's Wednesday. We don't have a lot of time. But I want you to take a look at this function here. I want you to close this, the end here. It looks like a roller coaster. Close this, and I want you to open this right here. Right here. How would you state the domain of this? Okay, in Algebra 2, you would have written x, which is your domain. It is between this number and this number. These are going by 5s, so from here to here is 5. What's the smallest number you have? It's -5. So the x value, and you should have learned this in Algebra 2, it's greater than or equal to -5, and it's less than 4. Well, in this class, you are going to replace the equal to sign here, the less than or equal to sign, with a bracket. And an open circle is a parenthesis. So in Algebra 2, if I asked you to graph x is less than 3, you would have done this. You would have put an open circle at 3, and you would have done that, right? But in Precalc, you're going to use, instead of an open circle, we use parentheses. This is called interval notation. Now, how do you write this? It looks like this, -infinity to 3. It looks like an ordered pair, because you read the graph from left to right. This is -infinity right here. Now, what if I said graph x is greater than or equal to 3? Well, in Algebra 2, you would have used a closed circle, and you would have shaded this way. In Precalc, instead of a closed circle, you are going to use a bracket. So a bracket replaces the closed circle. How do you write this answer instead of writing it like this? It's going to look like this, a 3 with a bracket, and it goes to +infinity. So now I want to see, we're going to spend time on this tomorrow. How would you write this domain instead of writing it this way? how would you write it with interval notation? Remember, we always start with the smaller number. It's going from -5 to 4. So you're gonna write -5, comma 4. The -5 gets a bracket, whereas the parenthesis goes with the 4. So it's an interval from -5 to 4. How would we write the range, I'm sorry? What's the smallest number here? This is the y value. The range, we would have written y is greater than or equal to, let's say, -3.5. And it's less than, what's this number right here, 4? Less than or equal to 4. Well, how are we gonna write this in interval notation? Bracket, -3.5, comma 4 with a bracket. What if I asked you to evaluate this function, f of -1? So this is your x value. You're gonna go to -1 on the x-axis. Where does this graph reach? What's that number? What's the output? In 4. And if you have f of x is equal to -3, I'm asking you what x values give you an output of -3. Well, let's find -3 on the y-axis. Here's -3. So I've got 2 spots right here. What would be the x value? I'm going to say 2.5 is one answer. And there's another answer. Let's say 3.75. I'm going to guess. Okay, so for homework, I have some problems I need you to practice. We will do more of this interval notation tomorrow. Yeah, can you stop that? Here's your